So our next speaker, Ms. Philippe Roux, is our head of systems of our iC3E, which is a France company. He is one of the iC3E co-founders and supervisors. So in charge with designing and installing turnkey and automated 3D printing cells at the company. And he also has a focus on the optimization of 3D printed concrete structures and are helping iC3E our customers to operate large-scale 3D printing systems. So, Mr. Philippe, are you ready? Hi. Hello.
Yeah. So hello everyone, and thank you for having invited me and giving me the opportunity to express, to share iC3's vision on 3D printing for construction. So my name is Philippe Roux, and I'm co-founder and head of systems for iC3. To get a very brief history, iC3 was founded in late 2015 and was initiated back in architecture school, where most of the soon-to-be co-founders met and took part in a research group that focused on how digital could impact construction in design phase, such as well as in execution phase. So concerning design phase, we developed a lot of optimization algorithms based on parametric design, such as a genetic algorithm, for example, and all sorts of way to design differently using more efficient and intelligence, bringing intelligence to the design. And concerning fabrication phase, we developed a proof of concept in 3 different areas: in 3D printing concrete, 3D printing clay, and also cable robots to control that. After that, we specialized in concrete because the market we envisioned with concrete was more ready than the other ones, and concrete application could find a way to have their applications develop. So we created iC3, and we focused on large-scale 3D printing in concrete. So now we have 2 main activities. First, we develop the technology to 3D print in concrete. And secondly, we develop new constructive systems that are efficient and could find their place in construction now. So maybe we can run the video that I have. Okay, so I'll present first the team that we have. So most of the founders, as I said, are architects, because we met in architecture school, but we also gather some other complementary skills, such as robotics, material sciences, civil engineering, mechanical engineering, and management, of course. And that's why that's how we think we have the skills to be active and bring intelligence to the way we design things. So we're separated. We have the top management, and we're separated between access, systems, and R&D. What we have is our core business model is systems. That's the part where I step up, which consists in designing and setting up complete automated printing system cells in industrials at industrials somewhere. But in order to justify the investment for the system, we need to develop a lot of applications that have a sense and can generate a market sufficient enough to justify the need for the technology. So we have an access part that we call access for the technology, which consists in organizing a lot of design thinking workshops to be present with architects, with engineering offices, with constructors, in order to bring everyone around the table and to think about what we can do to improve the way to solve their problems, knowing that 3D printing is possible now. And after that, we operate our own systems to build the different elements that we developed. Of course, because we have the relationship with the client directly from the access part, we know what kind of systems we need to develop, we need to improve, and that's where R&D is find its prioritization, and we can after that suggest to the industrial where we have a system the different tools that we develop aside to the 3D printing in order to be able to do the largest amount of designs. So I talked about the complementary skills that we have in intern, but also we have gathered an innovation ecosystem of industrial, such as ABB for the robot, Vinci Construction, to get all the issues that are generated in the site, Lafarge-Holcim for the concrete. We have also some universities such as Arts et Métiers Paris-Tech and École des Ponts, where we do some trainings. We have some partnership to connect all the future students to our technology, and also some certification organisms such as CSTB, which is the center of for construction in France. What is specific about our technology? I would say that we focus a lot on complexity of printing, so that's why we will never try to print a very straight wall, because what we find interesting in that is that we can bring complexity, bring optimization, and do applications that have a sense, that really are efficient in terms of cost, delay, etc. We focus a lot on quality. Our technology is full with sensors of every kind, so that we can really control very precisely the amount of material we deposit, and we control the surface conditions. And also we have an interest in combining multiple materials, so that we do not only use printing concrete, but we can print other materials, combine to that, and do also some hybrid operations, like to remove some part, to cut some parts, etc., robotically. Our technology is well, can be represented as such. So we draw a design using the different data that we gathered from previous experience. And using this data, we find the different parameters that will generate the geometry that we design. So in the physical world, I should say, the concrete is mixed and then brought to a buffer tank where the material is stirred, and then brought to our printing head, which is mounted on a robot, and where an additive is brought directly before extrusion inside the head. And this is what is specific about us, is that we can control the amount of additive that we put according to the design and the geometry, the part of the geometry that we're printing in the exact moment. So what are the challenges for construction? So what we have right now is we know that optimization is possible. We have on the left part topological optimization. So we know it's possible right now, very quickly to get a complex design that's effective afterwards. But what's difficult is when it comes to the physical world. Well, we still need to build very complex molds, having a complex rebars system and before casting. That's what we see on the right. And this is only two bricks, but with this context of a new industrial revolution, with the connecting everything inside the digital, we face a different technological bricks, such as being able to store data, a huge amount of data, being able to treat this data, to treat very rapidly, to react in the physical world, to control robotics, very complex design, etc. And we place ourselves right in the convergence of all these technological bricks that are now mature enough. So one of the first challenges that we see is about mass customization. So what we see today is that there's a huge demand for dwellings, and the current possibilities for construction are not regarding architecture. It consists in building huge towers, because this is the possibilities right now, and it's mass customization is present in every domain, but in construction it's difficult. There's very few attempts to bringing mass customization to architecture, like for example on the right side, where we see a construction from Chilean architect Aravena, who designed this system of houses using voids to be filled in with the envy of the current locator of the house. Another challenge is about health and safety, because as you know, construction is one of the riskiest domain, where there's a lot of accidents, and bringing robots to this construction can help reducing that. But of course, it doesn't mean that, as we can hear a lot, that robots will remove and replace completely workers. It means that robots should be placed in to do the different hazardous and very dangerous tasks, but workers should always be aside to control these robots. A third point, of course, is the cost reduction, and it's because, as we see naturally, to build complex shape, it requires a lot of money, and it takes time. So, of course, with 3D printing, it's the same cost to print a complex shape or a straight shape, depending on the volume used. But a second point is that we can optimize the structure, and we can put the material where needed and as needed. So I'll briefly talk about a few productions that we made. So, for example, this one that we did like 2 years ago is a pillar that we did in the south of France. And what's interesting is that it was placed in situ. It's in a gymnasium, and so it needed to have an insurance, to have someone to insure the place. And so that's why we developed the strategy of lost formwork. So the material that we print is actually the contour of this pillar, and the inside is filled in with UHPC. That is the material that is calculated to support the slab on the top. So only the inside that's filled in with a cast concrete is used for calculations, and the material that we print is acts like a lost formwork. So we built this 4 meter high pillar using 4 different parts that we cast in an industrial prefabricator and brought to the site and connected on site. A second example that we did was 1 wall and 4 pillars, as you see, for the Iris Concept House in France also. So the pillars, the 4 different design of columns that take the same strategy as the Aix-en-Provence pillar that I showed in the previous slide. So they are filled in with the UHPC inside, and the wall that you see was printed lie down. So we printed the contour, and then we poured concrete in the middle before taking it up. Another production that we did about infrastructures was a stormwater collector and sewer pits that we did. We made 3 of them afterwards in the north of France. They are interesting because today they need 3 weeks to stop the traffic completely, being able to dig inside the thing, put the complex formwork, and then cast it. And after that, we need to connect the different pipes with certain diameter, certain orientation, and that's complicated. So it takes about 3 weeks of traffic that's stopped. With our solution, it requires only less than a week. So we go there, we scan the place and the arrival of the different pipes, and we build. The model is ready, and then we just print in factory the collector with the pipes already ready, and then we just put it in place, cast concrete in it according to the calculations, and then re-put the traffic in. Another element that we did was this artificial reef in the south of France also, that we did with Seaboost. So they needed to repopulate the marine area with species of fishes that were disappearing. So it needed a different orientation of void, different diameter to attract again those fishes. So we worked a lot with the biologist to be able to get a specific design, respect the fabrication constraints, and also focus on the different aspects, such as, okay, we printed the piece, but then we need to move it, to place it in a truck, etc. And as the design is optimized and the different layers are very thin, the vibration inside the truck and the lifting operation can damage the object. So we also designed it using structural engineers assigned to us. Another example of things that we did is this series of furniture in collaboration with Studio 7.5, which is a German design studio. So we developed with them the textures, the new surface condition that we can attain, because a lot of people think that the layering aspect of inherent in 3D printing is mandatory, and we can only remove it by polishing the surface or having something in it afterwards. But we can use it as in this design to suggest new designs and use this layer aspect to generate things that we couldn't do before. So I think this one was pretty interesting. And yeah, that's it for this presentation. You see in the final slide the different coloring systems that we could attain using our technology. Thank you.
Probably you have questions for this session. Any question?
Hi, Mr. Roux. I am architect and researcher working in NUS only. So you seem to be in this business of 3D printing since quite a long time, and you seem very experienced. So from like a normal human being perspective, like you showed this stormwater collector versus those furnitures. So on your perspective, what do you think is like we are going towards creating something which is cheap, which is business like cost effective or viable through from a business perspective, or we are achieving something which is very unique, which is like very exclusive or customizable or close to nature by mimicking the biology which you do. So according to you, what do you think is the future of 3D printing?
I couldn't hear everything about what you said.
Okay, so on one side I have cost-effective technology. I'm saying that 3D printing is like saves cost, save time, save all these things, like what you mentioned in stormwater collector. And secondly, you showed the furniture. So what do you think is like, are we really trying to achieve through 3D printing? Like, since you are very experienced in this technology.
If I understood right the question, I think that it's very difficult to imagine before where we can find some value in pieces that have a sense. So by 3D printing, so we try a lot to see in every domain, every direction. So that's why we found this stormwater collector that has some potential and can interest industrials to invest in the system to be able to develop more other applications that will require some time more. For example, with the certifications, like certifications, I think will be an issue, as at least in France, will be a very long issue, and will require some time to generate application that we can imagine today. And to get to those applications, we will need to see in every direction.
Okay.
Thank you.
So, as I'm standing between you and the dinner, so let's first thanks Philippe and thanks for efforts. Join us from France. Thank you. And we are
Thank-
going to have our